This video is about ln and the quirks that it has. Now, this won't just be about how ln differentiates / integrates, but this will more be about effectively how you can use ln also in other things as well. Now, I don't know how much you know about ln, but ln is kind of the other side of e, if you like, because you've got e and you've got ln because ln is basically log to the base e, and the derivative of ln is 1 over x. So if you differentiate ln, you get 1 over x. If you integrate 1 over x, you get ln. So to give you an example, ln, we'll give you 3 examples to start with. ln, or should I say 2 ln x, ln 3x, and also 3 ln x. 3 examples. Now, when you differentiate ln, as I've said earlier, you get 1 over x. Probably should have written that a bit clearer in terms of d dx, but oh well. So you've got 2 ln x. Now 2 ln x differentiates d dx to become 2 over x. Remember that ln x goes to 1 over x. ln 3x. Now this is a mistake that a lot of people make. Remember the laws of logarithms. They still apply for ln. ln a plus ln b equals ln ab. ln a minus ln b equals ln a over b. If you just can't see that, I'll scroll up so you can. So ln 3x in this situation is actually ln 3 plus ln x. So when you differentiate it, it goes to 1 over x. Now, some people have asked me, why does it go over to 1 over x? The reasoning is actually quite simple. If you've got a function, for example, y equals x squared plus 3, when you differentiate y equals x squared plus 3, you get 2x. Because obviously the 3 is a constant and doesn't differentiate. Well, it's the same here. ln 3 is a constant, it does not differentiate. You'll always get rid of it. But that's the main thing to do. If you've got anything like that, you need to separate it out. 3 ln x, as I'm sure you can probably guess, is d dx equals 3 over x. Now then, we're going to move on a bit to how to integrate. So we've got 1 over x integrated becomes ln x plus c. So we're going to find a couple of examples to go and show you what that all means. We're going to have 2 over x, 3 over x, and we'll just pick 9 over x. They're all going to go to pretty much the same thing. So if you integrate 2 over x, that becomes 2 ln x plus c, 3 ln x plus c, and 9 ln x plus c. Now, I'm going to take you over one little quirk of ln, which isn't actually introduced to you until later chapters, but I think as we're discussing ln quite significantly, it might be useful here. If you have basically a fraction, and you've got, for example, x squared plus 4, and you've just got, in fact we'll say x squared plus 4x, and you've got 2x plus 4 above. Now, what you will have noticed is that the differential, represented here by f dash x, over f of x, you'll notice it's like that. This is something special in maths, and this goes to ln, whatever your function is, your f dash x, plus c. So in this case, what we've got is, if we just write that again a bit clearer, we write 2x plus 4 over x squared plus 4x, then we can turn this into ln x squared plus 4x plus c. Now, the last bit I want to go over on this is if you've got something like, if we just had x squared plus 4x, but instead it had just been x plus 2. Now, obviously you know that that is half of what the differentiated version is. So you could rewrite this as half 2x plus 4 over x squared plus 4x, which would then go to half ln x squared plus 4x plus c, because you're taking out basically a factor of half out the top. I hope this was useful. Thank you for listening.